It's not really. Okay, outline. I want you to know yourself. You're not, I'm sorry, you're not greatest. We all are not. So we do not have a clear idea what to do. But as you read, as you do some research, you end up being a greatest. Okay. Um, so to do that, I want you to pick up a topic that you can pick up from anywhere as far as it is related to your cyber security. If you are just new to cybersecurity, then you are not ready to be in this class, right? We all know that. You need to you need to know some basic courses about cybersecurity. Therefore, at least you understand what we or what the research papers are describing about. Okay. So steps you have to investigate. Oh, that's so broad, so broad. So we will take a look at that. How? How to investigate. Explore, yeah. If you know a topic. Topic, as I said, simply, let's see, where's my, oh, okay. I'm trying to get a pen. Topic is nothing but simply a keyword. If you have any buzzword, keyword, jargon, some keyword is so broad, some keyword is so specific. As you elaborate your research, the keywords needs to be more specialized. You can start with, for example, hacking, network hacking. Then network hacking is somehow to novice users. It is so specific, but to expert is not so specific. It's so still so broad, right? Network hacking. Then how do, how do you know? How do you know that uh, what aspects of hacking to what level of networks? So you have to answer to yourself. Am I going to do hack in network devices, a little more hardware oriented, from hardware to, for example, some software level, so that you want to hack the bits and bytes by looking at some bit. Um, I mean, depending upon the protocol, if you want to look into the IP protocol or TCP protocol or UDP protocol or whatever the protocol, then you need to unpack the packets. Packet is nothing but some like a pack topic. You have to pick up a list of keyword. Keywords. Okay. With this keyword, you need to investigate and explore and evaluate. How do you, with what? You need to have some um, research work done by someone else. Okay. Your research shouldn't be done from the scratch. You could do that, but it takes maybe 200 years. So don't try. Okay. You need to do something based upon some work already done. It's like building blocks. You don't have to dig out. Somebody already uh, stacked some stones up, so you can start from uh, some stages already established. How do you do that? That is something we call the research. Okay, this is something we already looked at. Bad reason is nothing better to do. If you read some articles, this is some F1 is something else. Right? Job tickets. Oh, I have to create some job tickets and ask someone else. And but take ownership. You need to do something on your own, and whatever you do, that is the owner is you. You are the owner of that work. So picking a topic, uh, some keyword, as I said, or some propositions, some statements. Um, Apology. What is the topic that you are interested in?
Have you tried to find out?
You haven't thought? Aaron.
Well, what I'm floating around my mind right now is what some of the guys spoke about last week, about the Wi-Fi, vehicles,
Something about Wi-Fi.
and the frequencies. You mentioned frequencies last
Oh
week.
yeah. So can you make some propositions based upon Wi-Fi and frequencies
Uh,
in your mind? If you do not have, that's okay. Then that is the time that you need to read the papers. Without reading papers, without knowing the work done by someone else already, it's very hard to start. But once you have some topic, keywords, that is the point that you can start with. Okay. Um, so, as an example, I can do something together with you so that I can open up. Oh, this that I did some. This is my lecture recorded.
Have you tried to find out?
That's my voice, right? So this one will be like that. What you need to do first, also those who are online, you need to come to Mercy, www.mercy.edu. And then there is academics and library home. And databases by name. And the digital libraries that we can find the most efficiently is from ACM. That is here, ACM Digital Library, Association of Computing Machineries. So if you click that, and then there is a text box that you can add the keyword. Okay. So for example, wireless and frequency. You can type this and click search. If you are not at Mercy campus, then it may ask you a login name and password. then you can use Mercy Connect login name and password. If someone else is still hard to come to Mercy, then you do not need to. You can simply type here Wi-Fi and frequency. You can start from here, or you can get some articles already published. Those are more academically well elaborated publications. If you do that from Google, for example, then it gives you a list of all kinds of matches. It's not really a publication, but any websites and all references. Okay, some of them are so not really related to what you want. Some of them are even sometimes better than the knowledge that you can get from these ACM digital libraries. For example, it gives you some idea of some, if you have a frequency bandwidth, then there is a smaller set of bands, we call that channels. So given frequency bandwidth, there are multiple channels available. You probably knew that when you set up your home wireless router, then you can see some channel setting, right? Usually it provides you 16 channels. Without setting it up automatically, you can set up some channels. Some channels are even wider, therefore channel after the next neighbor channel, there was some overlaps. If you open up those two neighbor channels, then a lot of scrambles. I don't want to improve. Okay, so back here, ACM. So you can click something that you want. Here, IEEE channel discovery in a outdoor environment. If you are interested in, then you can take a look at this. This is a recent publication, October 2015, where some of the workshop on real-world wireless sensor networks. Something about sensor network. Okay, another publication here in ACM Multimedia System Conference, and so on and so forth. A lot of publications, 20 articles on the first page, but how many pages? At least 10 pages. 20 times 10, 200 articles. So by having a simple set of keywords, you could have hundreds of matches. All are so valuable, so that you need to read those articles. As you read the articles, you may see you can modify or you can improve the sets of keywords in your mind, or you can elaborate further so that you can have more specific keywords. So more specific keywords that you can have as you read. Okay. So picking a topic requires a lot of reading. So without read, very hard to pick a topic. Number one. Number two, if you pick up without reading some articles, then it may not work. It's not really a good research topic. Or it may be just work that can be done by some company. It's not academically oriented research topic. How to manufacture is the key issue. If sometimes, if you pick up wrong topic, or sometimes there is a topic that needs centuries, a long period of time. You cannot get it done in one semester. One semester looks long, right? But it is not. In your case, this is an individual paper needs to be done in next 4 weeks. I think 4 weeks, right? Next to 4 weeks. So it should be done quick. This course requires 2 papers. First paper should be written by individual. Another paper is group work. Okay. So topic, picking a topic and choosing a topic should be done in 2 days effort. Okay, or 3 days. If it takes it longer, then you lose all the times. But as I said, it needs a lot of work. Work in this case, read. You can print out and read, relax and read. If you understand, or if you do not understand, that's okay. If you understand, that's good for you. If you do not understand, then it motivates you to dig out further, right? There are some scientific research or engineering researches. Scientific, it needs some result, and proven result. Engineering, some idea. It's not necessarily big research. It does not need any proof. But if you have good idea and do it, there's engineering, right? All the engineering works do not need to be proved, but need to be implemented. And cybersecurity is both. If you have some idea, or if you have some something to prove, that's okay. If you see some result, then you can, by reading some result of the paper, you can get some. It drives a new idea, that idea that you want to elaborate. For example, from the paper, you find out from some paper. It says a program runs locally against the stored data. Then you may think of locally and then stored data into 2 different sets of data available when you run your computer. Then maybe some cache memory needed. So you may start some cache examples, or some result claimed by a research paper that most programs are simple. Then you may argue that, it is not true. Not all the programs are simple. Program means it's programming or software packages, right? Not all of them are simple. Somehow there may be some difficult programmings available. One of the difficult programming is evolutionary computation. Programs itself needs to evolution. Okay. Your computer science or cybersecurity needs to, or can be motivated from some other disciplines. Evolutionary computation is motivated from biology, for example. In biology, any species, it evolves. Not any species. We know that some species evolves, right? This morning, recent days, okay. Another thing is the network traffic packets are standardized. Of course, it is standardized, right? But is it really always? Not necessarily, right? We do not know. At some point, some of the hackers send out some of the awkward packet sets that cannot be unpacked because it is not something that we can expect. That may be possible. How do you know then? There's some kinds of network threats and network defense. Picking a topic, have some relations about your idea or result will greatly help when going to get tough. Don't worry about people stealing your ideas. Your idea, when you first develop, you think that, oh, this is a good idea. Oh, I should not tell anybody else. It's not really true, right? If you tell your idea to someone else, although you think it is so great at that moment, but as you tell someone else, can be evolved much. So finally, you will have a better idea. So presentation is important. Most ideas are dead ends, few endures. So as you develop, you may have a dead end. That is a point that you can, for example, make presentation, and then someone else may ask questions. That gives you the path where there may be some breakthrough available. Stay on top of the events. This is a general idea, right? For example, read some of the articles from NIST, the National Institute of Standard and Technologies, NSA, National Science Agencies, some others, okay? Or some others here, www.mercy.edu/liberal arts/cybersecurity education center, and then there's a conference websites available. So all things. So now you need, once you pick up topic, keywords, then you have to ask yourself, has my idea been done before by someone else? Although you get that topic from reading someone else's papers, still you need to make sure that there may be some other publications describes about your idea. So you have to search. These days, because we have a search mechanism available, variety of search mechanism. It's very easy to find out. When I first studied 25, 30 years ago, it's very hard to make sure that there is no other similar work done by someone else already when I want to pursue, when I find out some topic, some specific topic, then I do not know. So it takes semesters after semesters to find out and make sure that there's no one else has done. No one else has tackled this type of research issues that I want to do. But now it's very easy. You can find it so quick. Number one, because search engine has been developed. Number two, all the people now wants to share the work they have been doing, right? They don't want to keep their work by themselves. Then no one recognizes. Once you have something, then try to post on the web page so that everyone can see it. So nowadays it's very hard, very easy to see, right? And then you have to answer why my idea is better. If you see there's some other similar work, not exactly the same work, but similar work done by someone else. Of course, always, if you have some issue, then done already. So for the same topic, There are so many different approaches to solve that problem. Your approach is one next. So altogether will be a bigger set of approaches. You have to now see, mine is better in this way, not better than all others in another way. So always there is some trade-offs. If you assume, and also there's some assumptions needs to be defined. If you assume, for example, if there's a network, then, oh, I want to stick to some protocols, very limited protocols, not all the protocols, and assume that the size of, for example, payload is not more than, say, 20 kilobytes or 20 bytes, so that I want to deal with only 20 bytes. That's doable. It's a handful of something, right? Don't be so ambitious so that you want to deal with all kinds of traffics. It's not possible, right? Why is my result to be important? You have to describe that. Importance of your research. That is also important, right? Who will care? This is a very good example, the question, right? You, by yourself, think this is very, very important, but if no one cares, then that is so significant to you only, but no one else. In some research, there are basically two measurements available: confidence and so forth. Confidence, your work should be confident, should be correct. Somebody says, oh, this is cool, this works. But you have to also think of supportance. Support this means, does it occur often? Somebody says, oh, I find out some attack, some antivirus program. If you have this, then you can defend this type of virus. But if somebody says, oh, that virus may occur once a million years. Supporting. It should be high supportive. It occurs so often so that your work can be applied frequently. So accuracy, so confidence, and then frequency. How often it occurs? You have to solve some problems, and problems may occur so often. So everyone should care. Explore your idea. Three approaches: build a prototype, build a simulation, build a measurement. Some measure. So that type of things is a measurement. There are a lot of measurements developed. Once you make some, then there's some measurement, right? If you want to think about financial sector, finance, financial markets, Wall Street. So what is the measurement? You develop some good programs, their concern is always the profit, right? Cost and benefit analysis, so that if it gives a high profit, then they will buy. If it is not, then they don't, right? There's some measurement. Yield. What is the yield rate? So that they want to put their investment on it. Measurement of the software packages, usually verification and validation, right? Usually what they do is, let's say you develop a system, software packages. Okay? Always two questions. Does your system, is your system implemented as requested? Is it a right, entire right system? Right means, first verification is, it is really based upon the requirements. Validation is it right system or wrong system? Is it fully implemented as requested? Or is it right? Is it wrong? Those things needs to be answered. Three approaches. Build a prototype. Little bit of implementation, okay? If we want to do implements. If we do not want, then develop the idea further and further. Give me some black diagrams. Whatever you want to do, then you need to decompose the work into smaller, so that each block needs to communicate. Hey, this block sends out some message to another block and return on others. And then what is the global input signals to your system? What is the global output signal from your system? That type of things needs to be described if we do not do implementation. But I strongly suggest you to do implementation. Build the simulation. Once you make it, then simulate it with some real data if you did implementation. If you do some theoretic work, then you can apply your synthetic data. You need to make some data and apply to your, for example, algorithm or some formula, some idea, some block diagram. There's a simulation. So not only describing your system on your writing, but also simulation to get a better grade. Sort of testing. If you make some idea, then test it. Show me your test, your own test. Test result. These days, the software implementation teams, they always have some test teams separated. So one team, they develop, and there's another team, they test it. Developers may be able to test it, but developers has somehow some bias in himself or herself, because they stick to some of the approaches they want to do, right? So when they test it, because they already test the way they tested, they develop, so there's no further testable available. But there is a third team never know about development, but they can test it all different kinds, which some of them never expected by the development team. Therefore, they can make their system more robust. In your case also, when you develop some idea or some implementation, then you can ask your friends or your whoever, hey, I developed the idea like this, and I test with the scenario that I have. Do you have any other scenario that you can apply this, which I do not expect so far? Okay, then that is a good simulation. Elaborates. So very uh, further and further, more developments. And as you do, then you have to measure latency, throughput, and fault tolerance. Throughputs, there's an input and output, some ratio, always, right? That is the idea of throughputs. Latency, does it return quick or very slow? Like my laptop, low latencies. Space. The first bullet is everything about the time, right? And the second bullet here, this is about time. What about the space? Oh, this works so fast, but it consumes a lot of spaces. It works so fast as far as you have terabyte memory. Memory, it's big money, right? Terabyte memory. So space is also important. Measurement, usability, and management. Is it good? Once it is done, oh, good throughput and consume small space. Is it easy to manage? Management is the issue. All the ideas for software are not really purchased for one-time use, right? They want to use continually or manage it well. Once you buy it, if you want to manage it, then oh, you have to call me and you have to purchase another, and that is not a good idea, right? It should be easy to manage also. Elaborates judgment. In general, it should be so exciting, right? Like a smartphone, wireless, sensor. If somebody says, "Oh, I want to work on Windows XP because Windows XP it needs a lot of enhancement. I have good solution to it." Too late, right? Drones. In our department, we still have one uh, flyable drones. We have 4 drones. Last summer that we used when we have summer camps here. 3 of them crashed. Some area, oh yeah, right up there. But one is still running, still flying well, I guess. I've never get back to that since last summer. But if you want to do the drone work, you could do that if you want. If you have a good idea. Only the problem with the drones that we have is that uh, very, very low expandability. I would like to attach some of the sensors on it and then flies. It's not well balanced, it's crashed. But if I place a sensor on the center, then there's a throttle and some of the propellers. Therefore, there's no space. I need to attach some surrounding areas. Then it's balance issues. It doesn't fly well. So we were not able to do that. I think that is a wrong choice. If we want to do that, then we need to find out. Yeah, when you purchase, you need to find out, depending upon what you want to do. Okay. The drones that we have, as it is, it works. But if you want to do some experiments, some addition to it, then it's very hard. Scientific methods versus computer scientific methods. Scientific, computer scientific. Scientific, control one parameters at a time. Computer scientific, change every time. Simple scientific or computer scientific. Not really. No magic. There's no magic at all. You have to touch every single points of the work that you want to do. Don't expect any magic. If you don't touch, it's not going to work. You have to touch every single spot of that area of your work. Not really. Resource, communicate your result. Talk verbally, and then in writing. That's what we want to do. Software release, so that someone else can let someone else run, so that the user can give you feedback. That is very, very important, right? This is the first module for today. We'll do the second module after break. You all know that. Another topic for the rest of today is the reading. How to read. Remember that to complete this the capstone project, the first individual projects, you have to pick up a topic. Once you pick up topic, then you need to elaborate further and further. Two components needed: thinking and reading. As you read, you have to think. As you think, you have to read more and more and more. Okay? So pick up the reference papers from the sources, either ACM, digital library, or any Google matches. To read articles and think. Do not rush to read the paper quick. You have to think. You have to always make some critique. Do not agree with the idea described in a paper. Try to disagree, which is not really good characteristics, but that is the way of the, research. Okay. Question: is it really true? Does it really work? Is there any other way that we could do? So from even one paper, you can get a lot of ideas, but it needs practice and practice. At the first time, if I recall, the reading papers to write, for example, PhD dissertation. First year, I think I read about 100 papers per month. So pick up one paper at that time. Pick up one paper and read. I put one notebook, real pen, paper, and then write the pros and cons. First of all, idea. What is the problems tackled by these articles? What is the pros and what is the cons? So one page per paper. Some paper, nothing to write, it's not worth, or simply because it is not related to what I want to, or sometimes it's too outdated, or sometimes there is no meat, just a story. Then nothing to learn, right? But keep doing and doing and spending several months, and there is no further reference articles that I can access, because I read about 1,000 articles that I know who is doing what. I remember all the researchers, and this guy is in what university, in what countries, and this guy started from these articles, and next topics that this guy tackled is this and that and that. So for each researchers, I know history. Oh, this guy did that, and this guy that. And then I can also link, this guy collaborate with that guy to write these articles, and this guy find out some other guys in other countries and collaborate and produce another articles, and so on and so forth. So a lot of networks of the authors in my mind. So, this guy is doing that and that and that. Finally, there are about 30 or 40 new topics available. And then what should I do? Should I do this area or that area and that area? The more preparation, the more papers that you read, the better results that you could have. Don't rush to do implementation. Okay, a lot of plans, preparations, and beef up yourself. Then you will get a good result. Another tip for you: do not defer writing to the end of your reading process. Oh, I want to start writing after I read 1,000 papers. A lot of waste time. I want you to, your writing start together with the reading. As you read, you can write some. As you read, write some. Not just to criticize, not just the critics on that papers. That is a separate effort. What I want you to do is start writing your paper. You may write two different documents. One document is your writing, that will be your deliverables. That is your submission at the end. On other documents, your own notes, your own criticize. So as you read the papers, you can make some notes on your own. But meanwhile, the tip that I stress to you is you have to start writing your your uh, requirements, requirements from this class. Do not write the last night before the deadline. Start writing right now. You can write start with some the title of section, introduction, problem description, and something like that, and then think, oh, what should I do? If you have no sentence to write, that's okay. If you have no sentence to write, then there is a time that you need to go back to the publication and pick up paper and read. Oh, this is a good sentence. This is a good statement. Oh, how can I revise this for me? You can revise. You can write it on your uh, submittable documents. Okay, research paper, primary form. Yeah, you can download any conference papers, journal papers, or any articles, any debates, discussions, anything, right? Or the description about the products from manufacturers. That also good. Criticize is important. This is what I keep saying to you, right? Understand the problem. In order to criticize, you have to understand, oh, what problems are tackled by these articles. Then they describe their approaches. Then read their approaches, and you can ask a question. Oh, does this work? This may work under a very strong assumptions. Then you can say, oh, this is not general solution. This works only if that specific conditions is met, but that conditions would not occur frequently. There's another supportiveness. Very, very low supports, right? That's your critics. Can you make it a little more general so that it can cover more general cases? Then there's a better solution, right? Understand the proposed solution, understand the competing approaches and designs. One paper proposes one approach, another paper, another approach. Can you compare them? If they are try to solve the same problem, right? You can clearly see, oh, this guy contributed in this way, the other guy contributed on another way, right? Some comparison needed. Um, as you read, you have to always ask yourself why this problem is important, why this guy is writing this. Is there any other way that we can do so that we can expect a better result? Then you will be famous. You will be richer, right? Evaluating paper. It's a little bit that we looked at already. What is the problem being solved? Is it important, relevant? Why? What is the prior work in this area? If you read the papers, then you can see, oh, this paper is written based upon someone else's work. You will be the next. Is the proposed solution clever? Cleverness is orthogonal to importance. You have to pick up important topic and then solve in clever idea. I'm not sure why clever, but some creative ideas. Okay. Are the assumptions or model reasonable? Some assumptions are very strong. Impact. Some work gives small good impacts, while lots of bad impacts, right? It's the same thing to medicines. Some medicines gives you a good impact so that it can cure some of diseases, right? But at the same time, always there are some bad impact, side impact. Side impact is so bad. Some medicines I'm really worried about when I am taking some medicine. Some medicines historically long proven medicine may be okay, like Tylenol or Alka shots if you have upset stomach and things like that. That type of things may be okay. Some other medicines it solves one problem, but at the same time it creates many other problems. I know one old person. When I met him first about 5 years ago, he was okay. He looked okay. He was about 70 or 80 years old. Sometimes he made quick anger, but other than that, he looks okay. His wife, I think he has some Alzheimer. So his wife had a lot of pain, sufferings from her husband because of that anger or sometimes unexpected reactions, or sometimes not remember, and not being quiet, so active like a little child. 80 years old with Alzheimer, then it's like a small kid, like toddlers, uncontrollable. So what happened is that she put him in a hospital finally, and hospital give him medicine, drugs, probably very, very strong medicines. I saw him a few months later. He looks like his brain stopped, I guess. Not really. His brain was so active before he took that medicine, and and his eyes has no focal points, and then no reaction, and no nothing. Um, so medicine keep him alive, but not in right way. That is a current medicine. Medicine.
So you're saying that he'll be alive, like biologically, but as a person, he's good.
Exactly. That's a sad story, right? So a lot of, I mean, medical medicines has that good effect and bad impacts. And our papers, our writing might have the paper that you read also, right? So, so find out those good impact and bad impact. If there is some papers could generate the bad impact, although the paper never describes about that, but if you catch such things, and that is the place that you can improve. Okay. Read slowly, take notes as you read. Note of your criticized documents. But I want you to write your paper as you read. You do not have enough time, right? So pick up one good paper, then read few paragraphs, and think, oh, what should I write on my paper? Do not copy, by the way. Okay. Change authors. Copy everything but author names. Ground rules. Try to understand. Don't be afraid to ask. Ask to yourself, or you can discuss with your friends. Be constructive. This is important. Be constructive. Don't say that, oh, this is garbage. Oh, another garbage. Another garbage. Try to find out. If it is garbage, try to find out how can you make it more constructive. Why you think that paper is garbage? Therefore, you can make it valuable and make yours valuable. In this course, we'll give you a research paper to read. Not well, the way that you can find the research papers. You know that, right? This paper is unpublished. Oh, you don't have to worry about this. Is something here. We'll discuss it in class. Your opinion, Yoon's opinion, my own opinions. Okay, this is it. So reading papers is important. What's left? We have then how to write. Did I post this also? No, I don't think, right? How to write up to this, 1, 2, 3, 4. So in the next class, we will do how to write. What we will do is next time, we start writing all together here. Okay? If you don't bring a laptop, that's fine, but bring paper and pencil. If you do not want to bring your laptop, fine if you bring your laptop, so that we can start writing here. Okay, all together, and then you can continue to add your writing. So next class we'll meet here, and then following 3 classes we do not meet, but you can do your own. That is what we do. Go back to your syllabus. Yeah. So 3 weeks we meet, and then 3 weeks we do not meet. But I think 7th week we'll come back to present your presentation, individual work. Any questions? Correct. Yeah, final paper of individual work. And after we do individual work, then we will do group project. So you do not have a lot of time to find your collaborator. You have to find out, even today, look around, who do you want to work with? And then form a team for your group project. As I said, group project, one team will be 2 students to 4 students. Exceptional case, I can allow 1. Exceptional case, I can allow to have 5 members in one team. But the ideal case is that 2 students to be one team, or 3 or 4. Did you decide already? Who do you want to work with? Maybe we can do that next week. Okay. So by next week, you better find out your collaborators. Therefore, right after your individual work presentation, you can. The ideal way of finding your collaborator is that you need to have a very similar topic of interest, or find out first, and then you can find out. You can elaborate your topics also. Okay. I'll see you next week.